9, 8, 7, 6, 5, 4, 3, 2, 1. Beginning pitch over. Stage 1 propulsion.
And with that, we have liftoff from Launch Complex 1 of our 48th Electron mission. Ready Aim PREFIRE is in the air and on its way to space with its NASA payload. Soon we'll be hearing the call out for max Q, otherwise known as maximum aerodynamic pressure, which is the point during Electron's ascent where the structure is under the most amount of stress. We'll hear from the GNC operator shortly that Electron has cleared that milestone.
High voltage battery discharge is nominal.
Cleared max Q.
And that was the max Q milestone, passed cleanly through by Electron as it carries on its mission to orbit for NASA. We're now at over 18 kilometers in altitude and moving at over 2,400 kilometers an hour. Next up will be 3 actions that are performed by Electron back to back to back. The first is main engine cutoff on the first stage, when all 9 Rutherford engines will shut
Guidance
down.
is nominal.
Next is stage separation, when the booster disconnects from stage 2. And then we will have second stage engine ignition, when the Rutherford engine on the second stage lights up to carry on with the mission. Those call-outs should be heard as MECO, stage separation, and second stage ignition. Let's listen in now.
Stage 1, propulsion holding nominal. Stand by for MECO in 30 seconds. "15 seconds to staging. Entered burner detect mode. MECO confirmed. Stage separation successful. Stage 2 ignition confirmed.
MECO, stage separation and engine start on that second stage. Electron is sailing smoothly through space so far. Now, that red-hot engine nozzle that you see on your screen is what's powering Electron's second stage, past 105 kilometers in altitude and 8,350 kilometers an hour.
High voltage battery discharge nominal.
Now, although Electron is moving at over 7 times the
Stage 2
speed of
propulsion
sound, there's
nominal.
very little resistance in the vacuum of space. So the next major milestone coming up is fairing jettison, where the 2 halves of the rocket's nose cone will separate and fall back to Earth. On missions like this, where the payload is a tiny portion of our overall mass, we leave the fairing connected for a little while longer than usual. Now, we should see that fairing jettison occur just after 4 minutes, and hopefully we'll get a good shot of them separating and falling on their way back to Earth.
Fairing jettison succeeded.
And that there was the call out for fairing jettison, confirming that the nose cone on Electron has split apart and fallen away in preparation for NASA's PREFIRE satellite to deploy.
As you can see, we're at T plus 4 minutes and 41 seconds. Electron is travelling at speeds of 10,800 kilometres an hour and at an altitude of 174 kilometres.
Stage 2 propulsion nominal.
We're now coming up on the moment when the second stage Rutherford engine needs to perform its next action, a manoeuvre called the battery hot swap. This is a move unique to our Rutherford engine. Since its pumps are powered by batteries, by this point in the journey, we need to swap out the draining battery packs for a fresh set of new ones that will keep the engine running. The old batteries will be ejected, and you can usually see that happen on your screen, so keep an eye out on the shiny object on the right of your screen just after 6 minutes into the mission.
Throttling down.
Hot swap successful.
Another milestone down, that was battery hot swap for the second stage Rutherford engine. All is continuing nominally for Electron, its engine and the mission as we carry on past 210 kilometres in altitude at more than 15,000 kilometres an hour. The next actions for the second stage will then be some of its last, including shutting down the Rutherford engine for SECO before separating the kick stage and NASA's PREFIRE satellite. Those milestones will happen back to back just after 9 minutes into the mission.
HVB battery discharge holding nominal.
T plus 7 minutes 46 seconds into this mission. The engine that you see on your screen is Electron's Rutherford engine. Now, as Kim mentioned before, the sea level version of that engine is capable of 5,600 pounds of thrust, and the vacuum version you see on your screen now is capable of 5,800 pounds of thrust. Now, Electron's total at liftoff is about 50,600 pounds, and compare that to a single Archimedes engine for our upcoming neutron rocket. The single Archimedes is capable of 165,000 pounds of thrust, which is the equivalent of 3 entire Electron rockets or 27 Rutherford engines on their own. It's now T plus 8 minutes and 30 seconds. That means we're coming up to the second stage engine cutoff for this launch, which is an action very similar to what Electron performed for the first stage separation earlier in the count. Now, much like before, Electron will power down its engines before separating the kick stage with its NASA payload. The timing of that shutdown is expected right as we reach our target 200 kilometre perigee. So let's listen out now for that engine shutdown and stage separation.
SECO confirmed.
Stage 3 separation confirmed. Nominal transfer orbit achieved.
And just like that, 9.5 minutes after lifting off, we are in space. The second stage engine has now shut down, and the kick stage has separated, ready to perform its own specific manoeuvres to place NASA's payload into its target low Earth orbit for the PREFIRE mission.
We have a while to go until the kick stage completes its first half lap of Earth. It's at that point, when we're on the opposite side of the sphere to where we are now, that the kick stage will fire up its Curie engine to circularize its orbit ahead of release of the PREFIRE satellites out into space.
We'll be back on this webcast to listen through those final calls at around T+50 minutes. We'll see you back here then.